I'm Bitwise Assembly, and in today's video, we're testing the limits of direct liquid recycling setups. Each test stand is a closed loop of packagers and unpackagers simulating a factory with waste liquid. The source is always set to 120, the production building is always set to 100. The wastewater is adjusted to determine the maximum wastewater rate. Tests were performed with Mark I and Mark II pipes. This test not being 50% is caused by the pipe length differences. The larger volume pipe can provide slightly more in each surge. This will be the main source of minor discrepancies in the tests. On the wall is every recipe combo that has a liquid byproduct and what percent that waste is of the total needed by the recipe. There are two on the wall where waste can be used in more than one step in the process. I've been saying liquid recycling rather than water recycling because in case uranium cell's byproduct is sulfuric acid. All of these recipes can be handled using at least one of the setups we'll be looking at today. This first setup was my go-to solution until recently. It uses an unpowered pump to remove the head lift from the source and a non-full pipe to remove the head lift from the waste. The water level in the vertical pipe is higher than the head lift from the source, which prioritizes the waste. This setup relies on the high return wastewater pipe not being full. When the pipe is not full, the machine head lift is not transferred through the pipe. When the pipe is full, the waste machine head lift gets applied to the source water. This setup directly came from the testing performed in the last pipes video. I know this is extremely clipped when used on a packager. On everything else, the pipe fits below. This setup here is how I deploy it with the manifold being Mark II pipes and everything else being Mark I. Future me here, speeding through this part where I re-explain the high pipe returns to steady state conditions based upon the transmission of machine head pressure. It did not add value. It is not the best or easiest solution. This next solution I was not expecting much from, but I tested it to be sure, and I could not have been more wrong. The buffer head lift disconnect functions in a similar way that the high pipe return does, since the buffer does not transmit machine head lift unless the buffer is full. The buffer itself provides a lower head lift than the water level contained within the buffer. When used in combination with an unpowered pump, the source side only provides water to the buffer when the water level is below the height of a pipe. This does break down if the buffer ever becomes full. This is due to the head lift of the wastewater being applied to the source side of the buffer. There is no real difference between Mark I, Mark II pipes, pumps, and buffers, with the exception of the Mark II buffer cannot be fully filled without a powered pump. Next, we have the VIP Junction from the pipeline manual, which performed well using Mark II pipes, but even better as Mark I. I did tests to determine which pipe segments are critical for the Mark I's performance, and I found that if you make these three Mark II, the performance drops to 75, which is lower than all of the pipes being Mark II. We're back to the bottom tap solution, which we developed over there. This time I avoided the clipping. The performance is less than the VIP Junction, but easier to deploy or hide in a build, since there are no pumps, buffers, or valves. Here are some examples of how I deploy it. I prefer to jack out my production buildings now. It gives me more options for belt and pipe work. To jack a building, I just build it on a 2-meter half foundation, and the legs will extend to the ground. This next testing area is for fun, is attempting to treat pipes like belts. Without any valves, there is no impact on prioritization, but if you add valves, it does prioritize. There was no real difference between Mark 1 and Mark 2 pipes. So let's add more connections. It turns out if you wanted to brute force prioritization, you could. This concludes my testing on direct liquid recycling. If you want me to cover cascading, slooping, and sinking solutions for waste liquid, let me know. But right now I don't think there's enough there to warrant a video. Thanks again for watching. I have updated the testing world download found in my channel links if anyone wants to poke around my tests.